Welcome to Module 10 Spatial Data.
And our objectives for the module are going to be just to learn how to encode quantitative values in geospatial data. And the three methods that we will use to do that are point size, point color intensity, and geographic region color intensity. So let's review a little bit. If you remember back when we first started talking about the pre-attentive attributes, the most frequently used and the best of the pre-attentive attributes are 2D position and length. Unfortunately, in geospatial design, you can't use them. 2D position is already being used in a map to represent geographic location, and length can't be used because there's no standardized baseline in order to use length. So here's a good representation of why you can't use 2D position and length in a map. So what's wrong with this visualization right here? Well, first of all, there's no baseline for your bar charts. So it's very difficult for the user to be able to tell the difference in the length between the different bars. And the other reason is that your bars are kind of all over the place. So it's kind of hard to tell which bars belong to which state, except in the very obvious ones. But some of them, it's kind of hard to tell. So you can't use 2D position. You can't use a standardized baseline. So that's why something like this is not a good thing to do. Fortunately, you can use other characteristics to encode your measures. That's using size, color intensity, and width. Although, unfortunately, these aren't the best methods for encoding, but they are what you have to use when you're doing geospatial design. So these are the following methods that you can use to encode your quantitative values in a map. You can use points of different size. That's the first method you should use. You can then use points of varying color intensity, and you can use color applied to geographic regions. Those are the three main ones. Now you can also do lines of varying width of color, but that's a special use case, and we'll conclude this lecture talking a little bit about those cases. So points of varying size. So points in a map are usually represented by a circle. You can use squares, but it should be a shape that's fairly simple, so it doesn't. So it's a lot easier for the user to interpret. But circle is usually the best. Size is a little better to use than color intensity to encode a value. So you should make sure you always use size first over color. And then this is called a symbol map in Tableau. So here is an example of a symbol map. Notice that in this map, the mark is the circle, and the way to encode the measure, which is sales, is by using size. So what they did is they drug sales up into the size mark card, and that gave each mark a different diameter based on the quantity of the sales. Now you can also use varying points. For points, you can use varying color intensity. If you have two sets of values to represent, you should always use size first, then color intensity. So here is pretty much the same sort of map as before, except you can see that size of the mark represents the measure of quantity, whereas color is representing the measure of sales. So you have two different ways of representing two different quantitative values in this map. Okay, color applied to geographic regions. You can use a filled map in Tableau where your color is applied to a geographic region based on one quantitative value. Now, when you do that, you can just have a simple filled map, but if you have another quantitative value that you want to add in, you can do that, and you can actually include up to 3 different quantitative values by mixing the color that's applied to the geographic region and then using point size and color intensity in your the mark that you choose to represent your other values. So this is a simple filled map in Tableau. So the quantitative value of sales is actually shown in each state. So you can see the color intensity. By looking at color intensity, you can see that sales in California are a lot greater than, say, sales in West Virginia, just by the color intensity. Now this is the dual axis map in Tableau. Now here, what you are seeing not only a region represented by color, but you're also seeing a point size that's representing some measure, and you're also seeing a point color representing another measure. So in order to make a map like this, you'll have to do a dual axis map, and I will show you how to do one of those in the upcoming exercises. Now, lines of varying thickness and color. These are very special use cases, and we're not going to actually practice this in this course because they're kind of advanced. But basically, when you have a line of thickness or color intensity used against a map, it usually is used to represent flow or migration. And this is probably the first example of a flow map. And this was created in 1869 by Charles Menard, who is a French civil engineer. And what he's showing here is Napoleon's march to and from Moscow during the War of 1812. And you can see that the lines represent the number of troops that he had. And the top line, the tan one, is the march to Moscow, and then the black line is the march away from Moscow. And the thickness of the lines represent the number of troops that Napoleon had. So you can tell on the left-hand side, as Napoleon goes towards Moscow, the line representing the number of troops gets thinner and thinner and thinner. And then on the path back from Moscow, the line gets even thinner until it reaches its original destination. You can tell the difference between the number of troops that he started with and he ended with. So this is a really powerful visualization, and this was done way back in 1869. And this is actually the origin of the modern day Sankey diagram, which this is a Sankey diagram right here. And Sankey diagrams are really cool to be able to do. There's not a really easy way to do them in Tableau. Unfortunately, other visualization tools do a much better job at it, particularly Power BI has a feature already built in. As long as your data is organized in the correct manner, it makes a really quick Sankey diagram for you. In Tableau, you actually have to do a lot of manipulation to get something like this working. But Sankey diagrams, you have to be very careful if you want to use one. They're very cool if you have only a few variables involved. Like for this one, it's very easy. You're just looking at married and pets and happy. If you were to multiply the options in each of your quantitative values, let's say, you know, if you take major, for example, college major, and you know how many different majors you can select, and then you want to view that over time. So like say you want to evaluate all your undergraduates starting in their freshman year and track them all the way to their senior year, and how many times students change majors. You could do that, and I practiced trying to do that, but it's just so complex that the visualization doesn't work the way that you would hope it to work. It results in something like this. where, yeah, you can see that there is a lot of migration and a lot of transition from stage to stage, but it's almost impossible for the user to be able to track all these individual lines. So that's why Sankey diagrams are cool, but they're often not very usable. Now this is another type of flow diagram. So this is just an airline map. Shows all the different flights for that United Airlines takes. You can actually do this in Tableau as well. This is an example of how to do that in Tableau. But again, this is very advanced, and we're not going to cover that in this course. But just so you know that is an option out there for you. So that is it on the lecture for this module. It's pretty short. We're going to be spending more time actually in the practice exercise, and then you're going to be doing some really fun stuff in the graded exercise. So I hope you guys have fun with this module. It's mapping is one of my favorite things to do in Tableau. It's pretty cool. So I'll show you a bunch of different options that are available, and I hope you guys enjoy it. Thanks.